Namaste children, I am Ramchandra Bhatt. Welcome to Samveda e-learning program. In this chapter, you are going to learn about very important concepts of carbanion compounds, that is the session number 4. Now let us see what are the important points that already you have learnt. That is nomenclature of carbon compounds and the structures of various hydrocarbons and functional groups, methanol, ethanol, methanoic acid, chloromethane and so on. And also you studied chemical properties, that is the combustion process. Now let us move on to today's important concept. The list are combustion with or without flame, and then oxidation reaction, addition reactions, substitution reactions, then properties of ethanol. These are very important learning points of this session, that is session number 4. Now let us understand these concepts in detail. Now only oxygen in the air is used for combustion. You can recall this one. If you are having a mixture of oxygen and ethane, it is burned for welding. Can you tell why the mixture of ethane and air is not used? Think and tell. Now you know, in the atmosphere the percentage of oxygen is just 21%. If you are using only oxygen, you are getting 100% oxygen. Where you are getting more energy? Yes, that is, if you are using oxygen, you are going to get more energy. For the welding purpose, we need a large amount of heat to fuse the metals. That is why the mixture of oxygen and ethane are used. Yes, I hope you understood this one. Now let us move on to how do substances burn? You know, that is the addition of oxygen. Here I am showing animation. Observe this one carefully. Here you are seeing the flame. Sometime flame is observed, sometime there is no flame. Now observe this one. Are you finding any flame here? Why? What makes this difference? Are you thinking? The charcoal burns without flame. What is the reason? You have to think. The reason is, this is because the only vapors are produced, then they catches the fire. Hence, when you are burning, the atoms or molecules of those substances converted into vapor, those vapors will catch the fire. That is the reason why the wood and charcoal, when it is ignited, when the volatile substances are produced, these catches the fire and you are seeing the flame, right? What will you attribute to the yellow color of the candle flame? Observe here. What are you observing? It burns with yellow flame, indicating there is an incomplete combustion, or it may contain unsaturated hydrocarbons. Due to incomplete combustion, the candle produces sometime carbon monoxide and carbon particulate matter also. That is the reason why it burns with this yellowish flame. In the last class you observed that when LPG is burned, it burns with the clean blue flame, right? The luminous flame and the gaseous substances, they are interrelated. A luminous flame is seen when the atoms of the gaseous substances are heated and they started to glow. I think now you understood the reason behind the various kind of burning. The color produced by each element is a characteristic property of that element. Now you see what are the different flames. They are so beautiful, wonderful. Now you can recall the Diwali crackers. why they are burning with the different colors. I hope you got the idea. The crackers are having various metallic oxides. When they burn with a characteristic flame. Now let us perform an activity, that is how the ethanol is oxidized, then what happens. You have to take small quantity about 3 ml of ethanol in a test tube and you have to warm gently. You should not directly heat it because the vapors produced will catch the fire. It is a dangerous one. That is why you have to warm it gently in a water bath only. The next one, you have to add 5% solution of alkaline potassium permanganate drop by drop. This is very important. If you add suddenly, what happens? I will show the experiment. Now let us see the experiment. Observe the experiment carefully. Now ethanol is taken in a test tube. Now let us add small quantity of potassium permanganate, purple colored liquid. Now let us add some alkaline substance NaOH. That means we are taking alkaline KMnO4. After some time, let us observe decolorization. What is this indicates? What is the role of potassium permanganate here? Potassium permanganate acts as a strong oxidizing agent. Now you are seeing here, this is the KMnO4 solution. When you add drop, initially what you are observing? Initially color of KMnO4 is discharged because it is converted into potassium sulfate and manganese sulfate. These are colorless substances, hence you are not seeing any color initially. During this process, excess amount of oxygen is produced. That oxygen combines with ethanol and converts that one into ethanoic acid. Why does the color of potassium permanganate is not disappear when excess amount of KMnO4 is added? That is because already reaction is completed, there is no more ethanol. That is why KMnO4 remains as KMnO4, hence there is no color change. What is this? This is the potassium permanganate crystals. These are called as oxidizing agent. The chemical substances which are capable of adding the oxygen to a initial or reactant, they are called as oxidizing agent. What happens to them? They were reduced, but they oxidize the other substance, hence they are called as oxidizing agent. Here you are seeing potassium permanganate. What is this? So beautiful, colorful, orange colored crystals they are. Once again, they are also example for oxidizing agent. This is potassium dichromate. So beautiful, right? Now these compounds convert alcohols into carboxylic acids. When you add KMnO4 or when you add acidified potassium dichromate to the alcohol and if you heat, it is converted into carboxylic acid. Here you are adding the oxygen, hence it is an example for oxidation reaction. Now see here this animation, observe carefully. When the alkaline KMnO4, that is a potassium permanganate, and acidified potassium dichromate, they were added to alcohol, they convert alcohols into carboxylic acid. What are you observing here? 2 hydrogens were removed. Removal of hydrogen is, yes, oxidation. Addition of oxygen. During the reaction, potassium permanganate or potassium dichromate, they generate oxygen. That oxygen, that is called as nascent oxygen or atomic oxygen, that combines with this alcohol and converted into CH3COOH, ethanoic acid. Now let us write the equation. When ethanol C2H5OH or CH3CH2OH, when that is heated with alkaline KMnO4 or acidified potassium dichromate, it is converted into CH3COOH. Here removal of hydrogen and addition of oxygen, both you have seen. Let us see one more experiment, that is what happens when K2Cr2O7 that is added to ethanol. Shall we see? Right. Ethanol is taken in the test tube. Let us add potassium dichromate. Now let us add acid, sulfuric acid concentrated. What is the color? Color changes into green. Light green color is observed. Here potassium dichromate breaks up into chromium compound, that is green in color, hence this imparts the green color. What you are seeing is because of breaking down of the oxidizing agent that furnishes the oxygen to the reaction and oxidizes alcohols into carboxylic acid. Now let us see one more type of reaction. These are called as addition reactions. When hydrocarbons like alkenes and alkynes, which are called as unsaturated, these react with the hydrogen and there is additional product is formed. When unsaturated hydrocarbons, they add hydrogen in the presence of catalysts like palladium, nickel, platinum to produce saturated hydrocarbons. This is called as addition reaction. What are the catalysts? Catalysts are the substances which increase the speed of the reaction. They do not involve in the chemical reaction. Before the reaction, after the reaction, they remains as it is. Such compounds increases the rate of reaction are called catalysts. In our body also we have several enzymes. They also perform similar function. Now let us see the equation of this reaction. Here you are seeing alkene. The R represents any alkyl group, that is methyl, ethyl, propyl, whatever it may be. Alkane minus hydrogen is equal to alkyl. These alkyl groups attach to carbon. Between two carbon there is a double bond. When you heat this one to high temperature, nearly about 200 degrees Celsius, in presence of nickel catalyst, hydrogen gas is passed through these hydrocarbons. They are converted into saturated hydrocarbon. Here you are seeing single bond. That is how the hydrogenation also takes place. Now let us see the animation. What are these? Hydrogen. Now you are seeing alkenes. Observe the animation carefully. Now you are seeing there is double bond breaks. Then what happens? Now you are seeing single bond is established. This is hydrogenation or addition reaction. Only unsaturated hydrocarbons undergo this reaction. This is in presence of catalyst nickel. What are you observing? These are oils. This is also an example for addition reaction as well as hydrogenation. Here the oils are heated nearly about 200 degrees Celsius in presence of catalysts like nickel, and hydrogen is added. Then you are seeing here double bonds were broken. Only see here there is no double bond. They are converted into single bonds. That is the conversion of oils into fats. Vegetable oils generally have long unsaturated hydrocarbon chain, while animal fats have saturated carbons. Then which one is the better? Here you are seeing oils and dalda, vanaspati or hydrogenated oils. Usually animal fat generally contain saturated fatty acids which are said to be harmful to our health. oils with the unsaturated fatty acids should be chosen for cooking. Why? This is because these oils contain double bonds, means they are more reactive. Then in the body they decompose very easily, they broken down easily and digestion completed faster rate. Whereas in the case of these animal fats or hydrogenated oils, they contain single bonds, means they are less reactive, more time is required to break down, and they were accumulated in the body, leads to obesity. That is why we have to use polyunsaturated PUFA fatty acids, polyunsaturated fatty acids. Now let us move on to another kind of reaction, that is substitution reaction. Already the saturated hydrocarbons are fairly unreactive and they are inert in the presence of most of the reagents. However, in the presence of sunlight, these undergo substitution reaction at faster rate. For example, when methane reacts with the chlorine in presence of diffused sunlight or sunlight, this is very explosive reaction, then you are seeing the substituted product, the chloromethane. All the bonds between the carbon and hydrogen were broken and you can get substituted product. Chlorine can replace the hydrogen atoms one by one. It is called substitution reaction because one type of atom or a group of atoms takes the place of another. A number of products are possible here. Such more and more products are possible with the higher homologues. Probably you are familiar with chloroform. What is that? Earlier it was used as anesthetic substance. CHCl3 is the chloroform, CCl4 is carbon tetrachloride, is very important organic solvent. Now let us see what happens here. The black colored hydrogen, observe that one. Now see the chlorine in presence of sunlight breaks up into chlorine atoms and this attacks the methane, and then what happens here? This is the substitution reaction. Alkanes undergo substitution reactions very easily. Now we came to another important organic compound, that is ethanol. Ethanol is very important organic solvent. Let us study the physical properties of this organic solvent. Ethanol, commonly known as alcohol, it is a liquid at room temperature. This ethanol is soluble in water in all proportion. Now what is the melting and boiling points? The melting point of alcohol is 156 Kelvin, which is extremely low, hence it is used as antifreeze. Now the boiling point 351, 78 degrees Celsius or 351 Kelvin. You are seeing here many products, these are contain alcohol as an ingredient. It is active ingredient of all alcoholic drinks. It is a very good solvent and it also used in the medicines such as tincture iodine, cough syrups and many other tonics. Now alcohol is an additive in the petrol. This is the very important one. What are you seeing here? The E15, 15% of ethanol is added. So in near future we can use ethanol as a major fuel in all the vehicles. Alcohol is a very good fuel because in excess of oxygen it produces only carbon dioxide, means it is a cleaner fuel and also it yields very good amount of energy. Here is the equation, C2H5OH plus O2 gives rise to CO2 plus H2O. Heat plus light. one more thing is left for you, you have to balance this one. Dear students, try to balance this equation. Check whether it is balanced or not, otherwise you have to balance. Consumption of this alcohol in small quantities leads to drunkenness. Even though this practice is condemned, it is a socially widespread practice. It is deadly dangerous. Then it also affects our CNS. Consumption of large quantity of ethanol reduces normal metabolic processes, and also it affects central nervous system. Then what happens? Then intake of even a small quantity of pure ethanol, which is known as absolute alcohol, can be lethal. Probably this picture symbolizes the impact of alcoholic consumption. Alcohol affects our personality. What are the other things? Alcoholism causes mental confusion, drowsiness, lowering of the normal, it lowers normal inhibitions, and finally stupor. And the individual may feel relaxed without realizing that his sense of judgment is affected, sense of timing is affected, and muscular coordination is lost. These are seriously impaired when the person consumes alcohol. That's why it is dangerous practice. It lowers our normal metabolic activities, it inhibits various biological activities. What do you mean by denatured alcohol? Name itself suggests denatured. Ethanol is very important industrial solvent. To prevent the misuse of ethanol produced for the industrial use, it is made unfit for drinking by adding some poisonous substances like methanol, very dangerous chemical. Then the dyes were added so that they can see the color. The copper sulfate, poisonous substance, also added. This alcohol is said to be denatured, which is made unfit for consumption by adding some chemicals. Now methanol, a poison. Intake of methanol, another alcohol, in very small quantities also causes death, deadly dangerous. What are you seeing here? It is the liver. Methanol oxidized to methanal, an aldehyde in the liver. What happens then? See here. When methanol reacts rapidly with the components of the cell, it coagulates the protoplasm, which is similar to that of boiled egg. What are you seeing here? The cell content, the protoplasm becomes hard, that means the death. One more thing, it affects the vision. When methanol, it affects the optic nerve, causing blindness. So these are the dangerous chemicals. Now see here, reaction of sodium and ethanol, very important reaction. You should write the equation also. And now see the activity. Drop a small piece of sodium about size of a couple of grains of rice into ethanol, that is 100% pure alcohol, which is called as absolute alcohol. Now what are you seeing here? Probably you are seeing some bubbles, right? What do you observe? You are seeing some gases evolving when sodium reacts with alcohol. What is that gas? Sodium, when reacts with ethanol, it produces sodium ethoxide plus hydrogen. Now tell, what is that? You are right, it is the hydrogen gas. Now another product produced is sodium ethoxide. How will you test this gas? Let us test the gas. Observe carefully. You have to listen the sound. Try to listen the sound. I collected hydrogen gas in soap water. Now you are seeing the hydrogen gas bubbles. When it is ignited, observe what happens. Pop sound confirms that is nothing but hydrogen gas. When you heat the ethanol to 443 Kelvin in presence of concentrated sulfuric acid, there is a dehydration of alcohol which yields ethene, which is unsaturated hydrocarbon, alkene. The concentrated sulfuric acid acts as a dehydrating agent during this reaction, which removes the water from the ethanol. Let us see this one with the help of animation. You are seeing here water comes out from the ethanol and it produces ethene. Here you are seeing ethene, right? Let us test what we learned. Are you ready? Yes. Here is the first question. What is the first question? What is the role of sulfuric acid? It acts as oxidizing agent or a reducing agent or a dehydrating agent or hydrating agent. What is your answer? The answer is it is a dehydrating agent. Next question. The role of this substance is it is an oxidizing agent or a reducing agent or a dehydrating agent or hydrating agent. What is the answer? The right answer is it is an example for oxidizing agent. These are potassium dichromate crystals. Now, next question is dehydration of alcohol yields ethane, alkenes, alkoxides, sodium methoxide. What is the answer? The answer is alkenes. Next question. Oxidation of methanol in the liver gives methanol, ethanol, methanal, methanoic acid. The right answer is it is aldehyde methanol. This compound undergoes hydrogenation. What are the compounds? Your options are, the first one is ethane, methanol, ethanol and lastly ethene. What is the answer? Let us check. The answer is ethene. Dear children, till now we discussed many concepts. Here are the questions for homework. Why incense stick initially burns with luminous flame? The next question, write the differences between substitution and addition reactions. The third question is explain oxidation reactions with suitable equations. The fourth question, what is the role of nickel in the hydrogenation reaction? The fifth one, conversion of ethanol into ethanoic acid is an example for oxidation reaction. You have to explain with suitable examples. The last question, which among the following undergoes addition reaction with suitable reason? Methane CH4, C2H2, ethene, third one ethanol, fourth one ethyne C2H2. Dear children, till now we discussed very important concepts and so many experiments, activities I conducted helped you to understand these concepts very well. Let us meet next class. Till then, namaste.